Good afternoon, my dear students. My name is Dr. KCH Apparao, working as an associate professor in Mechanical Department, Institute of Aeronautical Engineering, Hyderabad. Okay, in previous classes, we discussed the convection topics, just like boundary layers, thermal boundary layer, and hydraulic boundary layer. We saw that. We also discussed the thickness of the boundary layers and thermal boundary layer thickness. And we also see that some numericals on the forced convection, just like flow on a flat plate. So if it is flow is forced convection, then we derived the rate of heat transfer. Okay, so before going to just like convection through some inner flow, like cylindrical flow. Okay, so it means fluid flow through the some cylindrical pipes, like that one. So before going to see that type of flows, just we will see the dimensional analysis. We will see the importance of dimensional analysis. Why you have to study about the dimensional analysis? It is very important. Okay, so because in conduction only few parameters are there to explain the concept of rate of heat transfer. Just like Q is equal to conduction, you know that thermal conductivity into area into temperature difference by thickness. It means K, the thermal conductivity, area and length. So these three parameters are there to explain or to find the rate of heat transfer. But in case of convection process, convection means heat transfer takes place from the solid to fluid or fluid to fluid. Okay, suppose this is the solid surface, you know that the flow is like this one. So fluid is flowing on the solid surface. So the temperature of the solid surface is Ts and the fluid temperature is equal to Tf. Okay, so here just like if the temperature of the solid surface Ts is greater than the Tf or T uh, infinity, ambient temperature or fluid temperature. So if it is this condition, it means Ts is greater than the Tf. Okay, then the heat transfer takes place from the solid to fluid, solid to fluid. So here fluid is flowing from one place to another place. It means you know that too. So convection is mainly it is associated with the movement of the bulk movement of the fluids. Okay, so without movement of the fluids there is no heat transfer takes place through convection. So in the bulk movement of particles means just like flowing of the fluid means there are so many parameters are there, just like density, viscosity, kinematic viscosity, dynamic viscosity, Cp value, and thermal diffusivity, and so many parameters are there, just like uh, thermal conductivity of the fluid also. Okay, so many parameters are there, but we cannot explain the flow direction or flow process by based upon these all the parameters. So it means we cannot explain the effect of each parameter on the flow of the fluid. Okay, so it is very complicated. So to rectify this one or to resolve this problem, just like we use the dimensional analysis process. So that is the importance of the dimensional analysis. So we'll see first of all what is the importance of dimensional analysis, why how to study about the dimensional analysis. So what is the use of this dimensional analysis in convection process mainly? So it is a mathematical method, so in which physical quantities are expressed in terms of their fundamental dimensions. Okay, so fundamental dimensions, you know that mass is the fundamental. So dimension, so length is the fundamental dimension, time also fundamental dimensions. So mass, so units of mass is equal to, it is weight, m represented by length l, time t. So these are the fundamentals. It means all the quantities, quantity of density, quantity of viscosity, and quantity of cp specific heat, and the quantity of uh, tau, shear stress, all the parameters so are expressed in terms of the fundamental dimensions. Okay, so just like such method, this method is called the principle of dimension analysis. Okay, so this method can be applied to all types of fluid resistances and heat flow problems and many other problems in the fluid mechanics and thermodynamics. So it is very useful to solve the complexity. So we use the dimension analysis. By using the dimension analysis, we just like we combine these parameters, quantities, into some dimensional ratio, some ratio, just like some numbers, just like Prandtl number, Reynolds number, so Nusselt number, these numbers. You will see. Okay, once, one by one. Okay. So these equations, the equation produced by this method, okay, so also gives the non-dimensional context which governs the problems under the consideration. So this non-dimensional constants are very important in engineering practice. We'll see one by one. So just like particularly the heat loss by convection, you know that it is extremely complex process. Heat loss, just like solid surface. So flow is like this one. Heat loss by convection process. It means heat takes place from the solid to fluid or fluid to solid, based upon the temperature. So okay. So it is very complicated. We already explained that one. So because there are so many parameters in the fluid flowing, so you know that number of parameters are there. So it is difficult to study the effect of each variable in this process. So variable with respect to density, and variable with respect to uh, viscosity, dynamic viscosity, with respect to kinematic viscosity, with respect to specific heat, and with respect to tau, and with respect to just to so just like thermal conductivity of the fluid. So many parameters are there. So it is very difficult to study the effect of each variable in this process. Okay, but it is possible to investigate experimentally and express scientifically the results of any one geometrical configuration. Okay, so by using the dimensional analysis, we prepare the some geometrical configurations. Okay, so that is important. The major advantage of the dimensional analysis is to reduce the number of variables in a problem with the help of the dimensional analysis. It means we can combine all the variables into some dimensionless groups. Some dimensionless groups. You know that we already saw that some dimensionless groups, just like Reynolds number, rho u d by mu. Okay. So Prandtl number, we already saw that Prandtl number. So nu by thermal diffusivity by nu. Okay. So some Nusselt number HL by K. So these are the parameters, just like Nusselt number. It means the fluid properties. What are the properties of density, viscosity, and just like pipe diameter, velocity also, and kinematic viscosity and CP, specific heat, and thermal conductivity. So all the parameters are converted into some dimensionless groups, just like Reynolds number. So it is the group of density and velocity and diameter by kinematic viscosity and dynamic viscosity. So it means if you compare this one, the just like mu units equal to rho u d. Okay, so just like we can combine the density, so mass upon volume, velocity, so length by time into distance L. So just like so here velocity, mass upon volume is L cube. So here L cube, it means mass by L into T. So it means m into L minus 1 T minus 1. This is the formula for this one. So uh, for this value. So you can solve this later. Otherwise, you will go some confusion. Okay. So it means uh, so because in convection there are so many parameters, fluid parameters. So we cannot study the effect of each variable or each parameter individually. So we can combine these parameters or these physical variables into some Reynolds number, some dimensionless groups, just like group of Reynolds number, group of Prandtl number. Okay, so the combining of this one Nusselt number. Okay, you already saw in previous classes, Nusselt number is equal to C into RE to the power of A and Prandtl to the power of D. It means by using the Nusselt values, Nusselt number and Reynolds number and Prandtl number. It means by using the Reynolds value, Prandtl value and Nusselt value, so we can study the and we can find the rate of heat transfer of the fluid. So if you know the rate of heat transfer, automatically you can find the rate of heat, just like if you know the heat transfer coefficient, sorry, if you know the heat transfer coefficient, then you can find out the rate of heat transfer. It means so all the parameters are converted into some dimensional groups. By using the dimensional groups, we are finding the just like heat transfer coefficients. So that is the advantage of dimensional analysis. So by using the dimensional analysis, so by the help of the dimensional analysis method, we combine the variables, different variables which are included in the fluids. Okay, all the variables converted into some dimensionless groups. Okay, so in convection, just like you know that for forced convection and natural convection, in forced convection based upon the Nusselt number, Reynolds number and Prandtl number, by using these numbers you can study the forced convection process. So just like for the natural number, just like you have to use that there is no Reynolds number, just like by the help of the Prandtl number and so by using the so one more number is there. So okay, by using other numbers, so by using those numbers we can explain the just like convection, so free convection process. We'll see in previous classes also we derived just like we study the forced convection processes, just like Nusselt formula is equal to just like capital C into RE to the power of A into Prandtl to the power of P. So by using these relations, we derived the heat transfer coefficient. So if you know the heat transfer coefficient, just you can find out the rate of heat transfer. So that is the main advantage of this dimension analysis. We'll see how to combine these variables, or how to these combine convert these variables into dimensionless groups, how to divide or how to combine these different variables of the fluids into dimensionless groups. So that is very important. We will see that one also. Okay, so we will see some basics for the for solving of the dimensional analysis. So you know that dimensions and units. So you know that a dimension is the type of physical quantity. Unit means assigning a numerical value of the that quantity, just like uh, so you know that SI units are preferred for this work mainly. Primary dimensions, you know that primary means mass, that is the primary length, that is the primary, just like time primary, and temperature. So these are the primary dimensions. Mass is represented by capital M, length is represented by capital L, and time is represented by capital T. In some books, in some textbooks, time also represented by small t, and temperature is represented by capital T. In some textbooks, so temperature represented by theta. So you can show that one. Like, so you know that SI units of the mass is the kg, and length is the meter, and time always seconds, and the temperature is kelvins. So these are the parameters. Okay, so some more additional dimensions also there, just mainly for the uh, circuit branches, like mm, for electrical properties, electrical current is the basic one, and luminous intensity, so candela, so capital C, also just like a basic, and amount of substance, the moles, number of moles. So these are the just like basic dimensions. Mainly we use these four. It means mass, length, time, and temperatures. So by using these dimensions, we can convert the parameters into some dimensionless groups. We'll see how to divide that one. Okay. Here just like some symbols and dimensions of that particular physical quantity also given. So just like area, dimension is equal to uh, L square, means area is the length into breadth, or length into breadth. So length, it is represented by L, and breadth also, that is meters, so represented by L. So L square is the just like a dimension for the area. Volume, just like length into breadth into height. Height also measures in meter, breadth also measures in meters, length also measures in meters. So L into L into L, so L cube. So that is the dimension, basic dimensions for the volume. Okay, so second moment of area, just like that is the L to the power of 4. So these are the values. So similarly, velocity, you know that velocity is equal to distance by time. So distance is measured in meters, m, length, so L by time, so t. It means so LT minus 1. Okay. Similarly, acceleration, just like velocity by time, so one more t. So it means LT minus 2. Okay. So similarly, angular velocity. Okay. So that is the omega, you know that. So 1 by t. So next one is the force. F is equal to ma. M is the mass, represented by capital M. Acceleration due to gravity, that is LT minus 2. Okay, it means the basic dimension is equal to MLT minus 2. Okay, so similarly, just in this way, just we can convert the all the parameter physical quantities into basic dimensions, just like. So these are the basic dimension formula for the all the parameters, just like density. We'll see. So mass upon volume. So density rho is equal to mass upon volume. So mass upon volume. So mass means m, by volume means length into breadth into height. So length to height to breadth to all the measured in meters means L into L cube. So m by L cube means m L minus 3. So that is the density. Okay. So similarly viscosity, so that is the m L minus 1 T minus 1. This is the final formula. We will derive that one also. Similarly kinematic viscosity, so you know that formula. So kinematic viscosity mu is equal to dynamic viscosity by rho, and surface tension formula is like this one. So in this way, just like we can convert all the physical quantities into dimensionless, in some dimensions. We can write these some dimensions. By using the dimensions, we can convert these physical quantities into some group of dimensionless group. Like we'll see some example for the uh, viscosity. You know that tau is equal to mu into du by dy. So you know that formula. Then we find the dimensions for the uh, dynamic viscosity. Mu is equal to then tau by du by dy. So tau is the force of an area. You know that force of an area divided by velocity. Du is the velocity, by dy is the distance. Okay. So then force is equal to mass into acceleration m. So force ma mass into lt minus 2. So m lt minus 2 by area. Area is equal to L square divided by velocity m lt minus 1 divided by distance L. So these are the parameters. Okay. So if you solve that one, so completely you can write like this one. Just here I'm explaining. Okay. So force is equal to mlt minus 2. So because force is equal to m into acceleration, mass is the m, L is the lt minus 2. So mlt minus 2 by area is equal to L square, velocity lt minus 1, length, so distance is length L. So if you just like cancel the L and here L, just like here, so 1L, here L cancel, just like finally we'll get the, so m L minus 1 into T minus 1. This is the unit for the viscosity. Then you can find out the kinematic viscosity by the help of the dynamic viscosity, because density, you know that mass upon volume. So mass is m by volume is L cube. So m L cube. So by using the density and dynamic viscosity, you can find out the kinematic viscosity formulas. So in this way, just like we can convert the all the formulas, or we can write the just dimensionless values for the all the physical quantities. So okay, next one, in case of Reynolds number. So because it is a dimensionless number, you know that formula for the dimensionless number, Re, Reynolds number, is equal to rho ul by mu. Okay. So dimensionless means the about denominator numerator dimensions should be equal to denominators. Okay. We already derived that one. Mu is equal to m L minus 1 and T minus 1. So it means the rho ul should be equal to this one. Okay. So here we can see rho ul. Rho is the density, mass upon volume. So mass into L minus 3. Okay. So mass upon volume. Volume is L cube. Then m L minus 3. Okay. So into velocity. Velocity is equal to, you know, the distance per time, L T minus 1 into L length. Okay. So distance length. If you solve this one, just like you can write this one, just like L minus 1. So t minus 1. So m l minus 1 t minus 1. So it means the denominator dimensions equal to numerator dimensions. Then so Re is the dimensionless number. So there is no influence of that one. So in this way, just like we can convert the all the parameters into some dimensionless group. So it is a group, just like, so the group is simply called as the dimensional Reynolds number. Okay, so in this way, just like we can write Prandtl number values, we can write these Stanton number values, and we can, so there are so many numbers, dimensionless groups are there. Nusselt number also, so Nusselt number is equal to HL by K. Okay, so it means thermal conductivity, so K rate of heat transfer into L. So it means the dimension value should be equal to this one. So thermal conductivity units, you know that M thermal conductivity, so you know that one. So K is equal to Ka into temperature difference delta T by L. So this is the watt into length L by temperature T or theta into L square. Okay, so it means, so just like so thermal conductivity, units of thermal conductivity, watt for meter kelvins. Okay, so just like rate of heat transfer, so units of that one is equal to H is equal to watt per meter square Kelvin. These are the units. So just like if you take one more meter here, this one is this one cancel, then HL should be equal to K. So in this way, just like the numerator dimension should be equal to denominator dimension. So then, so this value is a dimensionless value, or this dimensionless group. So this is the Nusselt value. So in this way, just like we can convert the all the physical quantities into some groups. By using those dimensionless groups, we can solve the, or we can study the rate of heat transfer process, and we can find out the heat transfer coefficient with by the help of Reynolds number, Prandtl number, and Nusselt number. So it means by using these dimensionless groups, we can find out the, and we can study the rate of heat transfer in the fluids. So that is the main concept of this one. So conversion of these quantities into some dimensionless groups is very important. Okay, to solve this one, or to perform this dimensional analysis, there are some methods in which Buckingham's pi theorem, it is very important theorem. It means the conversion of physical quantities of the, or physical properties of the fluid into some dimensionless groups. So to convert those parameters into dimensionless groups, we will use the Buckingham's pi theorem. So by using the Buckingham pi theorem, so we can convert all the parameters of the fluids into dimensionless groups. We'll see the just like a process of the Buckingham pi theorem. Okay, so just like in a problem, so n relevant variables are there, just like physical quantities. There are n physical quantities are there. Properties of the fluids are there. Okay, so next m independent dimensions are there. M is the independent dimension. So basic dimension, you know that mass, length, time. If the temperature also is there, then you have to consider the data. Then independent variables should be 4. So if you number of variables is 7, just like, okay. So then so it can be reduced to relationship between the n minus n non-dimensional parameters. So we'll see some parameters, just like terms, pi terms. So pi 1, pi 2, and pi 3, and pi m. Okay, so we have to identify the number of these parameters, pi terms. So pi terms is depend upon the n comma m values. Okay, so it means pi times number of pi times is equal to n minus m. Okay, so n is the number of physical properties of the fluid. M is the basic dimensions, independent dimensions, means mass, length, and temperature, and theta. This one. Okay, so n is equal to suppose n is equal to 7 and m is equal to 4, then 7 minus 4, so this is the 3. So 3 pi terms are there, pi 1, pi 2, pi 3. So 3 relations we have to find out this one. Okay, so to construct these non-dimensional groups, okay, choose m representing the just like we have to uh, write the take the parameters for the m like based upon the geometry means length and the diameter. Okay, you have to consider under the geometry values. Next one is the velocity of the fluid. Okay, so we can take that one. Next to flow parameters, so that is the third one. So in order way, just like you can take. Okay, so flow parameter, density and viscosity, so these are the flow related parameters. So based upon these variables we choose the parameters m. Okay, so it means identify the number of parameters n and m values. So these are very important. So because uh, in geometry we'll see the just like okay, we can take this one. So based upon this process we can choose the n and m values. Okay, you can write pi times. Pi times is equal to first to take variable parameter into just like choosing m values, just like scale 1 to the power of a, and the scale 2 to the power of b, and the scale 3 to the power of c. So here a comma b comma c are the chosen, just like so these are the parameters. They have to find these values with respect to pi times. Pi times means so m naught, l naught, and t naught. You can take this one basics. Okay, so by solving the just these abc values, and we will get that to some one relation, the pi term. So pi 1 term and pi 2 terms and pi 3 terms. So we'll get the pi terms in this way. Just like if you solve any one numerically based upon the Buckingham pi theorem, then you can understand easily. You'll see. Okay. For example, there are some relevant variables are there, a1, a2, a3, and 6. So 6 variables are there in a problem. Okay, so in this these 6 variables be expressed in terms of the basic dimensions. So these 6 variables should be converted into basic dimensions. Okay, so all the parameters should be write into mass, length, time, and temperature. Okay, so temperature you can t small t, or you can represent by t also, anything. So the number of independent dimensionless groups representing this phenomena, you know that one. So pi times it means 6 minus 4. So because we are taking the basic dimensions, these are the m value, and total values is equal to 6, and 6 minus 4 is equal to 2. So pi times is equal to 2. So function of pi 1 comma pi 2 equal to 0. So these are the expressed formula. So now we'll see the one example, then you can understand the Buckingham pi theorem easily. Okay. Okay, example is equal to r value and l and velocity and mu and rho density and thermal conductivity k. So these are the parameters so given to the mm, fluid. Okay, so totally 6 parameters are given. So it means 6 n is equal to 6. Okay, in which we have to identify the basic dimensions, length. So basic one, that is the based upon the geometry. Then velocity, based upon the velocity. And the third one is the just flow. So flow property is the density. So these three we are taking as a these three just like basic dimensions. So we can take this is the m. So n is equal to 6, m is equal to 3. Okay. So next m minus n is equal to 6 minus 3 is equal to 3. So it means there are three pi terms: pi 1, comma, pi 2, comma, pi 3. So this is the function of three pi terms. So we have to identify the, so pi 1, pi 2 and pi 3. We can find the relationship between pi 1, pi 2 and pi 3. Okay. So we'll see first of all pi 1 terms. Okay. So here just like these are the, we consider length as the basic dimension, velocity also basic dimension, and density flow parameters. So based upon the geometry, based upon the velocity, based upon the flow property. Okay. So how to choose these three one. If there is the temperature related parameter, you have to take that one. Then m will be 4 watt. M will be 4. Here there is no temperature. So thermal, it means kelvins. So we are taking m is equal to 3 only. Okay. So first pi 1 terms, remaining variables. This is the variable. This one is the variable. This one is the variable. Okay. So first variable r into just like length to the power of a, velocity to the power of b, and density to the power of c. You have to take this one. Okay. That is the pi 1 term. Here we can see. Okay. So that is the one example like this one. So one more example also here given. So the pressure drop, that is the del p, is expected to depend upon the gate opening, the overall depth d, velocity v, and density rho, and the viscosity mu. So list the relevant variables. So this is the formula problem is given. So the given parameters is equal to delta p and heat transfer, rate of heat transfer h, and d, and velocity v, and rho, and mu. Okay. So totally n value is equal to 6, in which you have to identify the m value. So in which m, you have to diameter d based upon the geometry, velocity based upon the velocity, and the density based upon the flow. So you have to choose this one. So this m is equal to 3. So next 6 minus 3 means 3. So you have to choose pi terms: pi 1, comma, pi 2, comma, and pi 3. So 3 terms you have to find out that one. Okay. So based upon this formula, so n minus m formula. So 6 minus 3 is equal to 3. So 3 pi terms you have to find out this one. We'll see this numerical. So here also just like so d have taken, velocity is taken, density also taken. Remaining parameters are variables. So del p and h, and just like mu. So these are the variables, remaining variables. So dimensionless formulas also given here. You can choose that one. So that is the um, del p. So pressure difference ml minus 2, t minus 1. Height is equal to length. So diameter, distance, that is the length. Velocity lt minus 1. Density, mass of one volume, ml minus 3. And mu, viscosity, so ml minus 1, t minus 1. Take that. Okay. So by using this one you can solve this numerical. Okay. You know that m is equal to 3. Pi 1 term, first one is the del p. So it means the variable, and diameter, velocity, and density, d to the power of a, v to the power of b, and density to the power of c parameters. Okay. So parameter pi 1. So pi 1 means dimensionless groups. It means M0, L0, T0 is equal to dp. You already know that formula, ml minus 1 and t minus 1 into distance L to the power of A, velocity Lt minus 1 to the power of B, density ml minus 3 to the power of C. Okay, so you have to take the with respect to m, with respect to L, and with respect to T parameters. So with respect to m, okay, so here m power is equal to 0, power of m here, so there is no, it means 1, just like here C, 1 plus C. Okay. So 1 plus C is equal to 0. It means C is equal to minus 1. So we got the C parameter. Next, with respect to, so L, you can take with respect to L. So here power is equal to 0. Here L is equal to minus 1. Here L is equal to A. Here L is equal to B. Here L is equal to minus 3C. Okay. So here, so more parameters are there. Now we'll see the with respect to T. So here T power is equal to 0. Here T power is equal to minus 1. Here T power is equal to minus B. Here T power is equal to, here T is not there. Okay. So it means minus 1 minus B is equal to 0. Then B is equal to minus 1. So here C is equal to minus 1, B is equal to minus 1. If you substitute C and B values in this equation, okay, so you will get the just like A value also. So A is equal to plus 1 minus B plus 3C, means plus 1 minus B, B is equal to minus of minus plus 1, 3 minus C is equal to minus 1, so minus 3. So A is equal to 1. Finally A is equal to, so minus 1 plus A plus B minus 3C is equal to 0. So okay, and C is equal to minus 1 and B is equal to minus 1. So minus 1. So minus of minus plus 3. Okay. So if you solve this one just like automatically, you will get that one. So that is the value E is equal to 0. The finally we got that one. So A is equal to 0 and B is equal to some formula is written wrong. Anyway. Okay, B is equal to minus 1 we got and C is equal to minus 1. So if you substitute the values in this one here, pi 1 terms here, if you substitute here, you will get the pi 1 term. So pi 1 term is equal to dp and d to the power of so d to the power of 0 and v to the power of minus 1 and density rho to the power of minus 1. So it means we got that one. So delta t by and velocity into rho. So that is the v rho. So that is the pi 1 term. So now similar way, just like we can solve the pi 2 term. Pi 2 term is equal to next variable height into d to the power of a, v to the power of b and rho to the power of c. So here m to the power of 0, l to the power of 0, t to the power of 0, h is the length, d is the length to the power of a, velocity lt minus 1 to the power of b, density ml minus 3 to the power of c. Okay, so just like if you substitute that one, similarly with respect to m, So M formula will get one formula. With respect to L, we'll get the power formulas. We'll get another formula. With respect to T, we'll get the another formulas. So if you solve this one, automatically we'll get the small ABC values like this one. Here C is equal to 0, B is equal to 0 also, and A is equal to -1. You got that one. If you substitute here pi 2 term, you will get H. So D is D to the power of A, that is -1, and V to the power of 0, and rho to the power of 0. So it means H by D. So that is the pi 2 term. So in this way, just like we can find out the pi 3 terms. So finally, we got the pi 1 and 2, pi 2 and pi 3 terms like this one. Okay. So this is the pi 3 terms. So if you solve this one, so finally pi 3 term, we got the mu by rho Vd. So it means the final formula you got that one. So that is the pi 1 is equal to f of pi 2 comma and pi 3. This formula. So pi 1 is equal to del p by v rho is equal to f of so h by small d and mu by rho Vd. So this is the relationship. So it means the given parameters are converted into like in this relationship, just like this is the formula, just like Nusselt number is the function of Reynolds number and Prandtl number. So this is the dp by v rho is equal to function of h by d and mu rho v by d, this relationship. So by using these pi terms, we can solve the problem like this one. So this way we can solve the dimensionless group formulas. Okay. Now we'll see the one more problem. So this is the forced convection problem. You know that in forced convection, these are the main parameters are included. Rho is the included, and mu dynamic viscosity, and velocity, thermal conductivity, and Cp specific heat also included, and the length of the characteristic length. So that is also D also included. So you know that rho formulas, mass upon volume, ml minus 3, and viscosity already we derived that one, ml minus 1 t minus 1, and fluid velocity, so length upon time lt minus 1, and the thermal conductivity, that is the, so you know that the final formula is equal to mn minus 3 theta minus 1. So this is the temperature. So watt per meter Kelvin, you know the formula. Watt month, just like energy. So we have to take that formulas. So if you substitute all the formulas, we will get this one. Okay, that is the final dimension value is given, and the specific it also L square t minus 2 and theta minus 1. Okay, so characteristic length diameter, that is length L. So these are the parameters. So here basic parameters are 4. M is there, L is there, temperature is there, and thermometer temperature, time also there, and temperature data also there. So M value is equal to 4. N value is equal to 1, 2, 3, 4, 5, 6. 6 is this, so these are the function of H. So to find the heat transfer coefficient H, so we have to include all, it means so 3 parameters should be needed. So total variables in this problem is equal to H plus 6. It means so total variables is equal to 7. So 7 minus 4, it means 3. So pi terms, pi 1 and pi 2 and pi 3. So 3 terms is there. We have to find out the 3 terms. Okay, we will see that one. So H is the function of density, viscosity, and velocity, thermal conductivity, and the Cp and T. So these are the parameters which are included in the forced convection. You know that to find the H value, just we have to consider all these parameters. Okay, so conversion of these parameters. So these are the properties taken. So from the numerical also we saw that these parameters are taken from the data with respect to temperature of that particular fluid. Okay, So function of h, rho, u, mu, v and k, c, d. So these are the parameters. So total parameters is equal to 7. Okay, so basic parameters is equal to mass is there, length is there, time is there, and temperature also, theta is there. So these are the 4. So 7 minus 4 is equal to 3. So you have to find out the 3 terms, pi terms, pi 1, pi 2 and pi 3. You have to find out that. We'll see how to do that one. Okay, so in which just like we have to identify that one, which is the so based upon the geometry, how to take the standard dimension. Next, velocity based upon the velocity. Third one is the flow based upon the flow. You have to choose that one. So here just like uh, so parameters based upon the diameter, geometry you have taken the diameter d, velocity v, and thermal flow so mu, and the temperature, so thermal conductivity k. So these are the basic dimensions you have chosen. So in order you can take, so it means hd. Here you are also take the hd, v and mu k. Like this one also you can take. Okay, otherwise you can take like this one. So whatever you want to take, you can take. So pi 1 terms, it means m to the power of 0, l to the power of 0, t to the power of 0, theta to the power of 0. So mu, thermal conductivity, dynamic viscosity, you know that m l minus 1 t minus 2, 1 to the power of a. So thermal conductivity k, so ml t to the power of minus 3, theta minus 1 to the power of a. You know that one. Next, velocity, so lt minus 1 to the power of c. So diameter L to the power of d, and h, rate of heat transfer, you know that mt minus 3 and theta minus 1. So these are the values. So then you have to add the powers, because the bases are equal, then powers are should be equal. So here base is m, here base also m. Okay, so with respect to m we will get one equation, with respect to l we will get second equation, with respect to t we will get third equation, with respect to theta we will get the fourth equation. If we solve these 4 equations we will get the abc values. Then substitute these abc values in this pi 1 term, we will get the one relationship, means one pi 1 term. Okay. So with respect to power m, okay, so here 0, here 1, 1 is there, here 1. So next to with respect m, so here b, and here just like here a, so a, here b, and here just like all to the power of 1 only. Okay, so a plus b plus 1 is equal to 0. So then a plus b is equal to minus 1. So that is one relationship. Next, with respect to L, comparing the powers with respect to L. Here L power is equal to 0. Here L power is equal to minus a. Here L power is equal to b minus a b. Here L power is equal to c, and here L power is equal to d. Okay, here there is no L. So it means 0 is equal to minus a plus b and plus c and plus d. So this is the one more relationship. With respect to t, time. So here power is equal to 0, time here minus a, here minus 3b, here minus c, here so minus 3. So this is the one more relationship. Now we will see the comparing the powers of theta with respect to theta. Power is equal to 0. There is no theta here, theta is there. So minus b here, here theta is there. So minus 1. Minus 1 minus b is equal to 0, and b is equal to minus 1. So if you substitute b value in this equation, then a is equal to minus b minus 1. So b is equal to minus 1 and minus 1 minus 2. So a value is equal to minus 2. So b is equal to minus 1. Then a is equal to, so a is equal to minus b minus 1. So B is equal to minus of minus 1, minus 1. So plus 1 minus 1. So that is the 0. So B value is equal to 0. So if you solve this one, if you substitute the A value and B value here, just like we will get the C value. So you know that A is equal to 0 and minus 3, B is equal to minus 1 and minus C is minus 3 is equal to 0. Okay. So 3 minus 3 minus C is equal to, so C value is equal to 0 also. C value also 0. So in this way, just like we can find out the D value. So if you substitute the A, B, C, D value here, you will get the pi 1 term. So pi 1 is equal to mu to the power of A, it means 0. So k to the power of B, so minus 1. V to the power of C, that is 0. D to the power of D, so that is 1. Which is the parameter. So pi 1 is equal to finally, so remaining values DHHD by K. So this is the pi 1 term. So HD by K or HL by K, this is the, you know that this is a Nusselt number. So one term is equal to one relationship, dimensionless group. Okay. So pi 1 is equal to HD by K. If you solve that one like this one, pi 2 term, so next parameter, so H has taken, next is the density, how to take that one. So remaining A, B, C, D, same basic parameters. And if you solve this one, and we will get the pi 2 term. So pi 2 term is equal to, so finally mu to the power of minus 1, k to the power of 0, v to the power of 1, d to the power of 2. So pi 2 term is equal to rho vd by mu. So that is the pi 2 term. So similarly, pi 3 term also you can find out. So pi 3 term, if you solve this one, this is the pi 3 term. So pi 3 term, we got the this one. Okay, if you solve that A, B, C, D, so pi 3 term is equal to mu Cp by K. Mu Cp by K, you know that this is the thermal diffusivity. It means, so this is the Prandtl number relationship, you know that one. So finally, pi 1 is the Hd by K. So you know that this is the Nusselt number, you know the formula. Pi 2 is equal to rho v d by mu. So you know that this is the Reynolds number. Pi 3 term is equal to mu Cp by K. So this is nothing but Prandtl number. Okay. You know the formula. So that is the pi 1 is the function of so pi 2 comma pi 3. It means Nusselt number is the function of something constant to Reynolds number to the power of A and the Prandtl number to the power of B. So this is the relationship. So it means to find the Nusselt number, so it is depend upon the Reynolds number and Prandtl number. Okay, if you solve the relationship of Reynolds number and Prandtl number, you will get the Nusselt number. So by using these three numbers, just like Reynolds number and Prandtl number and the Nusselt number, you can find out the rate of heat transfer coefficient from this relationship, and automatically you can find out the rate of heat transfer. So HA into delta T. Right? So finding H, so in convection is very important. So we cannot find the H by comparing or by considering all the parameters. So that is very difficult. So we have to convert all the parameters into some numbers, just like dimensional as numbers. By using these numbers, you can find out the H value. So in forced convection, this is the forced convection numerical. So forced convection, so this is the, just like is associate with, it is depend upon the three dimensional numbers. So one is the Nusselt number and the Reynolds number and the Prandtl number. So by using these three numbers, we can study the forced convection phenomena, and we can find out the heat transfer coefficient. Automatically we can find out the rate of heat transfer. So the above correlation, so is generally expressed So this is formula. So based upon this, this one just like this formula is okay. So Nusselt is the constant of into Reynolds to the power of A, Prandtl to the power of B. So this is the very important. So by using dimensionless analysis, we can study the different flows. Either it is the natural convection flow and the forced convection flow, and the just like these values of A, B, these constants is depend upon the flow dimensions. If the flow is the just like external flow, just like flow on the solid plate, just like these a comma b comma c values will be varied, constant values are varied. Okay, if the flow is in some circular pipes, just like circular pipes and inner flow, so these c values and the c a b values will be varied. So finally, if you want to study the just like forced convection, so finding Nusselt, Reynolds number, Prandtl number is very important. Okay, so in this way, just like we can solve the different numericals of convection process by using the dimensional analysis process. Finally, dimensional analysis is very important process or a important method to convert all the parameters into some influenced dimensionless numbers. By using those numbers, we can solve the or we can study the forced convection or free convection. So thank you for listening this class. We will see few more numericals in next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.